In early 1943, invasion planning intensified. British engineers examined fortified coastal barriers. Concrete obstacles resisted conventional explosive breaching. Operational planners demanded rapid mechanical penetration solutions. Department of Miscellaneous Weapons Development received the request. The unit specialized in unconventional engineering proposals. Design Authority assigned the project urgent classification. Initial concept avoided direct human exposure. Engineers proposed a remotely delivered demolition device. The concept emphasized high kinetic penetration force. Circular geometry was selected for momentum efficiency. The proposed device used twin rotating wheels. Each wheel measured approximately 10 feet diameter. Central drum contained the main explosive payload. Payload weight estimates exceeded 1 ton. The engineers specified amytal as the primary filling. The detonation method required a timed fuse. Rocket propulsion provided the forward acceleration. Cordite rockets were mounted around the wheel rims. Each wheel carried multiple evenly spaced rockets. Total rocket count exceeded 70 units. Ignition wiring connected through a central firing circuit. Electrical continuity became an immediate concern. Prototype construction began using mild steel framing. Wheel rims were reinforced for rocket mounting loads. Initial assembly occurred at Leytonstone workshops. Fabrication tolerances remained relatively crude. Balance calculations assumed uniform rocket thrust output. No active steering mechanism was included. Guidance relied entirely on symmetrical thrust distribution. This assumption later proved critically optimistic. Early static tests verified ignition sequencing. Rocket exhaust produced substantial lateral vibration. Mounting brackets required additional reinforcement. Engineers increased bolt thickness after first trials. Wheel alignment procedures were repeatedly adjusted. Explosive filling was initially replaced with ballast. Test safety protocols limited personnel proximity. Remote firing lines extended several hundred yards. The first powered trial occurred at Westward Ho. Weather conditions remained within acceptable parameters. Ignition sequence initiated without delay. Initial forward motion appeared mechanically satisfactory. Within seconds, thrust imbalance became visible. Several rockets burned unevenly across the wheel circumference. Rotational oscillation developed immediately after launch. My device trajectory deviated from the projected centerline. Ground observers reported severe lateral wandering. The containment perimeter required rapid expansion. Multiple rockets detached during the powered run. Loose projectiles posed uncontrolled safety hazards. Trial termination procedures were poorly defined. Device finally exhausted fuel and halted. Post-test inspection documented structural distortions. Wheel spokes showed early fatigue cracking. Rocket brackets exhibited partial shear failures. Engineering staff recommended thrust uniformity review. Rocket manufacturing tolerances were investigated. Cordite burn variability exceeded predicted margins. Supply batches showed inconsistent propellant quality. Procurement offices disputed responsibility for variation. Additional static burn tests were commissioned. The results confirmed significant thrust dispersion ranges. Design team attempted compensatory rocket pairing. Opposing rockets were matched by test output. This adjustment increased preparation time substantially. Assembly complexity rose beyond initial estimates. Field deployment timelines became questionable. Despite concerns, trials continued under pressure. Second full-scale tests scheduled within weeks. Revised mounting brackets were installed. Electrical ignition wiring received improved insulation. Ballast mass more closely simulated live payload. Safety observers expanded the standoff perimeter. Ignition sequence again proceeded nominally. Initial acceleration exceeded previous test velocity. Vibration amplitude increased correspondingly. One rocket misfired immediately after ignition. Asymmetrical thrust induced rapid yaw motion. The device veered unpredictably across the test range. Ground personnel executed emergency dispersal. Several rockets ejected laterally at high speed. Observation teams documented significant safety deficiencies. Mechanical stress readings exceeded the design envelope. Wheel hub temperatures rose unexpectedly. Bearing lubrication proved insufficient under load. Design engineers specified heavier grease compounds. Maintenance procedures became increasingly complex. Logistics officers questioned operational practicality. Transport requirements exceeded standard landing craft capacity. Device weight complicated beach deployment scenarios. Naval planners requested handling studies. Results indicated slow unloading timelines. Exposure during deployment remained tactically unacceptable. Despite mounting concerns, development persisted. Project leadership cited invasion urgency repeatedly. Additional rocket suppliers were evaluated. Consistency improvements remained marginal. Engineers explored partial thrust throttling concepts. Mechanical governors proved impractical at scale. Electrical sequencing offered limited corrective potential. Steering control remained fundamentally absent. Further field trials were nevertheless authorized. Test crews reinforced the perimeter extensively. Medical teams were placed on standby. Weather remained calm during the next launch window. Ignition produced immediate full thrust output. Device initially tracked near projected heading. Within seconds, oscillation reappeared violently. Multiple rockets detached simultaneously from the wheel rim. Projectile hazards spread across the observation area. Control teams ordered full evacuation. Test was formally classified unsafe for continuation. Engineering review convened within 48 hours. Failure analysis cited thrust variability as primary defect. Structural fatigue was listed as a secondary concern. Guidance absence was noted as a critical limitation. Proposed redesign options increased mechanical complexity. Production timelines extended beyond invasion planning needs. Procurement authorities requested cost-benefit reassessment. Comparative studies favored conventional demolition methods. Project priority was quietly reduced thereafter. Documentation classified the device as experimental only. No operational units were ever deployed. Remaining prototypes were eventually dismantled for study. Engineering files were archived under restricted access. The Panjandrum program closed without formal adoption.